Hey folks, welcome to the Algebra 2 Unit 3 test prep video. I'm Mr. Recorder. First thing you should do, go to Open Class, click on the Unit 3 tab to open up the Unit 3 page, download the practice test PDF, print that baby out, and here we go. So factor each of the following. Look carefully at the structure and consider the best way to factor. Is there a GCF? That should always be your first question. Second question, is it a special case? So does this one have a GCF? There is no greatest common factor here. Is this a special case? It's not a sum or difference of cubes, and it is not a perfect square trinomial. This is not a perfect square. So it's just a regular old trinomial, and we're going to factor it using the big X. So A times C, 1 times 30 is 30, and then B is negative 11, and I need two numbers that multiply to positive 30, but add up to negative 11. I'm going to have to do negative times a negative in order to multiply to positive and add up to 30, and it looks like negative 5 times negative 6 is 30. And negative 5 plus negative 6 is negative 11. So, I started with just an x, so it's x minus 5 and x minus 6. So that's my answer. X minus 5 times x minus 6. Is there a GCF? Yes. 3 goes into all of the coefficients, and there's an x in each of the variables. So I can factor out a greatest common factor of 3x. And that leaves me with 2x squared. Notice if you multiply these back together, you get 6x cubed. Plus x, because 3x times x gives you 3x squared. Minus 15. Because 3x times negative 15 gives you negative 45x. Now, is this a special case? Or, no, it's not a perfect square. It is not a difference of squares. It is not a sum or difference of cubes. So I need to do the big X. 2 times negative 15 is negative 30. And then B is positive 1. Multiplying to a negative means I'm going to have 2x plus and 2x minus. And if I do a positive 6 and a negative 5, then positive 6 times negative 5 is negative 30. And positive 6 minus 5 is 1. But I can't have a 2x in both places, so it's going to have to divide out of 1. Here we go. So 2x divided by 2 is x, plus 6 divided by 2 is 3, and then I've already taken out my 2, so this one is 2x minus 5. And you can always double check your factoring to make sure that it multiplies out. Oh, what did I forget? Uh-oh, forgot my greatest common factor. So let me erase my box, give my pen back. So it is, the final answer is 3x times x plus 3 times 2x minus 5. And you can always just multiply it all out and make sure that you get this to make sure that your factoring is right. Another thing I can point out is that I could have written the answer like this. 3x times 2x minus 5 times x plus 3, and it would have been just as correct because multiplication has the commutative property. So it doesn't matter what order you multiply in. How about this one? Is there a greatest common factor? Let's see, 9 has only factors of 3 times 3. And 25 has only factors of 5 times 5, so there's no greatest common factor. But I notice that 9 is a perfect square and 25 is a perfect square. So if this was 3x plus 5 squared, as long as this works as long as this is 2 times 3x times 5. 3x times 5 is 15x, times 2 is 30x. So 3x plus 5 is the factorization of that one. Is there a GCF? No. This just has x's, this has 3's and y's as factors. But is it a special case? Yes, it is, because I can write this as something squared minus something squared. X to the 4th is x squared squared, and 9y to the 6th is 3y to the 3rd squared. Because 3 squared is 9, and y cubed times y cubed is y to the 6th. So now this factors as, remember, a squared minus b squared factors into a plus b times a minus b. So here my a is x squared, so it's going to be x squared plus 3y cubed times x squared minus 3y cubed. And as long as none of these two factors can be factored anymore, then I'm done. And it can't. The only possibility would be if this binomial here was a difference of squares. But since we have y cubed, we know it's not a difference of squares. Gregory is building a fence around his rectangular garden. The perimeter of the garden is 25 feet. The area is 36 square feet. Find the length and width of the garden. So L is going to be the length and W is going to be the width, and the equation for the perimeter is P equals 2 times L plus W. The perimeter is 25 feet, so that means that 25 is 2 times L plus W. And these instructions say to solve for W. So I'm going to divide by 2 first, divide both sides by 2, and I get 25 over 2 equals L plus W. And then to get W by itself, I just subtract L from both sides, and I get 25 over 2 minus L equals W. Let me just... And even though I erase, you can always pause and rewind if you want to see what was there. So this is the result of the last step, part 1. The equation for area is area equals length times width. Substitute the expression you found for W, which is this, in part 1 into the area equation. So area equals length times width. Well, what I'm substituting in is this 25 over 2 minus L. Oh, and I can also sub in for my area because I know what my area is. My area is 36. It says so right here. Alright, now it says to write the equation in standard form with A, B, and C as whole numbers. Alrighty, well, I'll start by distributing this L through the parentheses. And I get 36 equals 25 over 2L minus L times L is L squared. Then I want to get everything onto the left side and a 0 on the right side. So if I add L squared to both sides, and if I subtract 25 over 2L from both sides, on the right side I'm going to get a 0, and on the left side I get L squared minus 25 over 2L plus 36. it's close to standard form, but I don't have A, B, and C as whole numbers yet. But I can see a way to make them whole numbers if I just multiply everything by 2. So that gives me 2L squared minus, now the reason I'm multiplying by 2 is because when I multiply here, 2 times 25 over 2 is 2 times 25 divided by 2, that's just 25. Right? 2 times 25 is 50, 50 divided by 2 is 25. And then 2 times 36 is plus 72 equals 0. So this is our standard form. Now we're going to use the quadratic formula to solve for L. L is taking the place of x. So we know that A equals 2, B equals negative 25, and C equals 72. So L equals negative B, so that's the opposite of negative 25, positive 25, plus or minus the square root of B squared. Negative 25 squared is positive 625, minus 4 times A times C, all over 2A. 2 times 2 is 4. So this is 25 plus or minus the square root of 625 minus this. If you ask your calculator, it tells you 49. And then we got L equals 25 plus or minus 7 over 4. Well, 25 plus 7 is 32, so 32 over 4, or 25 minus 7 is 18 over 4. So this is 8 or 4.5. Alright, so now we just need to decide which one to use. Length is generally the longer and width is generally the shorter. So decide which value of L should be the length. Why, that'll be 8. And then we're going to plug that in for L in this equation right here. So W equals 25 over 2 is 12.5 minus the length, which is 8, equals 4.5. So the width is 4.5. So the length of the garden is 8 feet and the width is 4.5 feet. And that brings us to the end of part 1. Tune in again for the rest of this dealio.